Maybe he's on holiday in the Bahamas.
No. No, he isn't. I'm pretty sure.
I found it, Pedro.
Yeah.
So it's in the csolve, csolve CPP file, in the source of SU2 CFD.
So I'll share my screen then, so we can.
Nice, thank you.
All right, linear algebra, solve CPP. Yeah, do you have a line number or something we can jump to?
Yeah, so I'm using 7.0.4. So the line is 819. So it's basically the solve function.
Yep.
And it does say something, a word about the template types. It's assumed that the residual and solution vectors are always SU2 doubles, meaning that they're active in the discrete adjoint. So I'm not sure what does this really exactly means. Do I need to set up also the adjoint solver for the transitional model somehow?
You don't have to set up anything. So the way this is done is include solvers, solver CPP. Okay, so the way this is done is that you have the linear system vectors, the solution and the residual, and then you have the Jacobian matrix, and you have the linear solver itself. Okay.
Yes.
So what we do is when we differentiate the code in reverse mode, so for the discrete adjoint, we assume that we are differentiating the code around the point, around the converged point that gives you the residual equal to 0 everywhere.
Okay.
That is like the thing converged when you ran SU2 CFD, and now when you're running SU2 CFD AD, you are differentiating where this is 0, and this allows the matrix to be in a non-active type. So SU2 double, when you're doing the discrete adjoint, is not the normal double. It's an active algorithmic differentiation type that allows the recording to be made and so on. But the matrix, because the residual is 0, the matrix can be a passive type, and that saves a lot of time when you're then solving for the adjoint solver. And so the only thing you need to do is use it exactly like this. So if you have, you will probably use also this fields or these member variables for your transition solver, right?
Yes.
Okay. So you don't need to do anything then. If you just use these members, it's all done.
All right. Yeah, I was wondering because I still stuck with the implicit Euler iteration. It's exactly where my code is breaking. So I'm not sure if this model that I'm trying to implement is not pretty broad. So I'm just going to move on to LM, which is a pretty standard one, and try to fully implement that one, where there's a lot of documentation for it. So yeah, probably I'm just going to start doing that because the model that I'm trying to implement just is not working. So I'm not sure if it's more numerics on that model or something like that, or yeah, something that I haven't really catch yet in SU2. But I'll give it a try. Thank you, Pedro. I was just wondering what was this, but now it's
So,
way more clear.
but is it like exploding as in crashing, or it just doesn't converge properly, or doesn't give nice results, or?
No, it's not. It's diverging. So basically, I'm getting right now the error that I'm getting is here in the. Let me show you exactly where it's going to track it. When I'm solving the system with the FGMRS, it tells me that let me show you exactly where it's that let me see. That I'm getting a non-number when solving the linear system.
Well, I mean, there might be a variety of reasons why that happens. You can try and you can try and uncomment this line here.
Okay.
And this will trap nans. So it will make the code crash
Okay.
as soon as another number is produced.
All right.
So you might be able to track the source of what's happening there that way.
Okay.
But you might also, so it's those lines and these ones as well.
Okay. But at least that.
But you might also find some false positive because of other things in the code. But it's worth a try.
Yeah. All right. I'm gonna start looking into all this. Oh, I found it. It's telling me that the FEM RS orthogonalization fail, and then my linear solver diverge. So this is the.
Yeah, that's just the standard error you get from GMRes when when that kind of stuff happens. So when you get like divisions by zero or uh, you can also before you call the linear solver, you can just loop over the residual and the solution and see if you have non-numbers there.
Okay.
And yeah.
Yeah, I've been printing those, and yeah, like all of them are actual numbers. So right before getting into in the implicit iteration, right before getting into the solved system, the linear system. That's where I'm checking all my linear system residuals and my linear system solution, and I have no.
Do you have a branch with this work you're doing?
Yeah, I do. I haven't really sent I haven't sent it to you because I have a lot of comments and stuff like that are like, I don't know. I think they look kind of ugly, but I'll be super happy to share it if.
But is it on the SU2 repository or where is it?
Not yet. I'll upload it today then, and
okay.
And then I'll let you know, and probably we can share more ideas with that. Thank you very much.
We can have a look at it next meeting or something if you don't find a problem.
Sounds good. Thank you.
Right. What else have we got? Ole, you are here twice.
Okay, I'm closing this now.
No, it's good. We don't have a lot of people, so it's good. I think he closed the wrong one.
Yeah, maybe. You're still muted on this one, Ole.
And now he's back with a different caller.
Is this the third one now, or?
No, there's still two. I think it's okay. We don't have a lot of people, so it helps with the audience.
Right. Okay.
Do you wanna talk about the multiphysics stuff, maybe?
Yeah. Let me just. I was working a bit for this nonsense project that I'm working for. So I haven't had a look on the multiphysics stuff since we talked about it on Monday.
Don't forget this is live streaming, huh? Don't say your project is nonsense, because
you said no live streaming today.
yeah, but Tim gave me the key in the end, and
I see. Let me see. So this multiphysics simulations with many-to-many interfaces pull request is good to go now, or?
So I did some validation on the triple physics case with the discrete joint.
Yeah.
And now everything is looking okay. When we run the dependencies twice, yeah. Where was SU2 again? Mm-hmm. Yeah. This. So Yeah, so when we do this before evaluating the objective function, that case is fine now. And I think this will also impact the improve some of the results we got for the aviation paper. At least on the FSI problem, the discrepancy for the derivatives of drag were a little bit off.
Yes.
And I think the drag to evaluate drag, I think the gradients of velocity are still used. So I think this might improve it. I'm still rerunning those finite differences and stuff too.
Okay. Okay. I was just reading through this other comment that you wrote yesterday. I got rid of the zone-specific recording, this secondary cluster with all zones at once. So peak memory. Yeah, concerning peak memory. Yeah. From my side, it's fine.
Yeah, I think it's good if we have just fewer things to look out to look after, basically.
Yeah, that's right. That's mine. The screen adjoint fix for heat with mesh deformation. Yeah. So that was this JI problem.
Yeah, because that was crashing some. That was causing some issues with having just FEA and heat transfer, I think, because it's not symmetric. It's only in one direction.
All right, then I will just go through this pull request one more time tomorrow or on Friday, and then I guess we can have it merged by next week then. So
Yeah.
that it's merged by next week's meeting. Let's see what else is there. JST with matrix dissipation. All right. Bigger than expected.
What is?
JST scheme with matrix dissipation.
Oh, that's because it builds on the vectorization stuff. So the difference between that and the vectorization is maybe, I don't know, 200 lines.
So this vectorization, vectorized SIMD numerical schemes should be first.
Yeah.
Okay.
Eventually, yeah.
Okay. Good to know, yeah. Is there anything that you think is urgent? Or what's the most urgent one?
Urgent in terms of what?
Urgent in terms of what's most important to have it merged into develop.
I don't know. I think for fairness, we should just go bottom up and
yeah.
Whatever is ready for review or whatever.
So there's one by 5th of March by room.
Yeah, that's waiting some stuff. I think Rocco will, yeah, he'll have the label work in progress.
Okay. So then the next one. Okay, I guess the Nemo one, that's also work in progress, I guess.
No, that's, so far as they're concerned, I think it's done.
Okay.
Or ready for integration. And Katerina said she was working on other developments, but those would be different. Those are different branches.
Okay, so these would be then building on, the next ones would be building on top of this one here. Okay.
Yeah.
All right. Okay, good to know. All right. And then there are some by Brian. Yeah.
I just had a question about the Nemo one. Is there a reason we don't ask Katarina to merge when she's ready?
Well, I approved it, but I kind of said that because it's an entire solver, maybe it would be good to get a second set of eyes. But yeah, I mean, it can be merged.
Review. Okay.
Mhm.
I can go through it meeting, but later today or by the end of the week, I'll go through it again then.
Cool.
Tom, by the way, we started working on making this AIAA multiphysics paper. Now the journal one, I will send you the link to the journal version on Overleaf in a second. I'll send it to you via Slack.
This is probably still waiting for 7.1. State of the adaptive CFL. The first one was small, but then he submitted another pull request. Lost Ola.
Yeah. You were saying something about what? About the mesh adaptation and stuff?
Brian has his 2 pull requests. The one is still a work in progress with the slope limiter, but the first one was an update to the adaptive CFL, which he's then, if he's done the same changes in the second pull request, and this first one,
Oh yeah, update adaptive CFL.
Comparison. Things are in pretty good shape because most of the other pull requests are waiting on things or so.
Yeah, I think Tim and I were talking about this adaptive CFL, and the only thing was that some of the AD cases were failing, but with a very large difference in the residuals. So a lot of the cases only had small problems or small differences, but one of the AD cases was very different.
Number 1050 or 1036 or both?
1036.
Changes in those two? I was going to do a stuff to 1050, but I thought he made the same change.
Yeah, So there's something there with the AD.
Do we? I mean, it doesn't really make sense to have an adaptive CFL for the discrete adjoint anyway if we're just taping one iteration, correct?
No, I don't think so. I think the only, but that's what is that what we do already? We have it constant for the discrete adjoint, or?
I actually have to go look at that, whether when I first put it in, if I disabled it or not. Let me check. Didn't do anything because when you just start up the solver at the first iteration, you get the original CFL anyway, but let me look.
Yeah.
For outdated, I don't think I touched that, which means that's probably not working. Or a couple other special cases that I put in. Not the finite volume solver. I throw an error. Trying to do time marching. I throw an error. factors up and down are truly up and down, which we hadn't done originally, but was a good thing to put in. I don't have anything special for the discrete adjoint, so that means it is active when you come in, but it should just get the first CFL on the taping. Maybe there's some initialization issue, or perhaps if we just put in a check and disable it in the config options in discrete adjoint mode, that could end up just fixing that issue.
Okay. Hmm.
It's many or just a couple? Or? Like 10 failed cases for.
What? Sorry. When you start speaking, the sound is muffled, and then after like 1 second.
Yeah, I think my microphones on my headset are having trouble. Okay, yeah, people told me that the other day.
So don't stop talking.
Yeah, I was just going through. Yeah, I'll just have to keep talking continuously for the rest of the meeting. I was going through 1036, just looking at the errors in the test cases, and it looks like maybe 10 or so failures on the primal stuff, but then for the AD, I was also just checking. I was looking for the case you were talking about, but so from my point of view, maybe we should ping this thread. I can leave a comment and ask Brian to take a look at disabling the discrete adjoint or disabling the CFL adapt for the discrete adjoint. Try to give that a try.
Yeah.
Touched 1036 in a little while, so I don't know what his plan was anyway. Any other pull requests we want to go through, guys, or other topics?
No, really, we just have the usual suspects and not much else.
I'll take a look at the Nemo one when I have some time. I'll give that a second review so that Katerina can get that one merged. It's a pretty big one. So, and then I'll leave a comment on Brian's. We can end there. It's a pretty small crew today, so we can just pick up next week.
Yep, cool.
All right.
Then next week. Have a good weekend.
Thanks, you too.
You too. See you next week.
Bye-bye.